Hello, this is Carlos again, and I'm very excited to continue with this ninth section of the expert system course. Now we're going to discuss about the principal function of the Lex Analyzer GetToken function. So you remember we left with only one function to implement, and this is the GetToken. So we had to implement the build token function to build a token manually. This is useful for testing purposes. So we can demonstrate this going to the main to test it. This is the main. First we should type the headers. No. Also iostream and suddenly QTextStream. We're gonna use QTextStream to simulate the C++ layout to display the token of a lexem type. So let's create one and test if it's working. We're just creating an object QTextStream from a standard out stream of C++, and then a pointer to a prop lex analyzer. After that, we're going to call the build token function. So it's going to return a lexem. I'm going to put local O to pb build token. The first parameter is a type prop lex. No.
You are not going to do the lottery, right?
Hold on.
Huh?
Hold on. Hello world. So creating this local lexem object, I'm gonna just to demonstrate printing out the token and right. Let's build it and let's run it, and the application output, you can see that it holds the token and actually was a good building. Also you can see that the lexem is a public struct inside of the prop lex analyzer, and that holds the specific values that we set. And in this, we can continue with the GetToken function implementation. We won't use build token function because it's not adequate to create tokens manually. The aim of the prod compiler is to get what it wants to compile from a file. In the project case, a text file. This is because we're gonna to implement build token function due that it's gonna get lexems from the file iteratively. So let's start with the implementation of this function. It's returning a lexem, prop. No, it's prop lex analyzer, lexem, prop lex analyzer, GetToken. To make it simple to explain, we're going to develop a switch to handle different cases of words. For example, we can have this rule for example, and the next row is a comment. Okay, so because an atom or ID, we can tell ID, can be more than one char, in this example is animal 18. We need to hold a value until we reach a new operator, that is the implication operation. So in this case, it's gonna take every character until it reaches the hyphen of the implication operation, and then return the lexicon ID. So the get token is going to return first this ID, this lexicon type ID, and it's going to continue analyzing the file. When it finds the hyphen, holding another status to determine whether the next char is a left bracket or not. If it's a left bracket, it's going to return a left implication or a error depending on the case. When you finish the implication, it's going to continue character by character, building the next word and returning lexicon ID or error depending on the case. Finally, our compiler supports comments when it detects a pound sign, capturing words as a comment until it reaches the end of the file, of the line, sorry. After that, we're going to create a switch with all the different states. But before that, let's create a local lexicon and integer variable to hold the status. Lexicon and state, we're going to initialize it to 0. We also need to get the file from the stack and seek the position that we're going to left previously. So it's string dot set device to get the file to the stream input. I'm going to take the top one, stream seek last position. Great. So now finish that, we're ready to create an infinite loop that is gonna break until we get a lexicon, even if it's an error, and inside that the switch. So the while, make it infinite, and we start with a switch. Sorry. 0. Then we're gonna set different cases of n states. For example, the case 0 is to first letter found, and is first letter found. Case 1, it's break, is to left brackets found. Case 2 is for hyphen found. The case 3 is to ID building, ID, and the case 4 is for comments break. We don't need any default, I hope so. The letter that we are going to use is inside the while. going to implement in here. And it's a good opportunity to tell you that because we're building lexen of more than one char size, the IDs will need to verify if there is a pending char. That's what we're talking about. We were talking about that there may be different spaces. We can have a file with a lot of spaces between the ID and the implication operation. So our compiler have to deal with this. So we're just gonna to pop them until reach the operation. So we need to create the char. Hold on. It's qchar taken char. And this is the handling. And it's if. Remember that we have a container. It's a qstack. So I want to see the size. If there is a pending char, do something, and if not, do anything else. So let me think a little bit. So there is a pending char, and if the first character is a space or jump of line, we're gonna to ignore it. Otherwise, take it from the string. So is if pending chars, it's going to return a qchar reference, and the char is space. We want to assess if it's space or pending chars dot top the same char. Jump of line taken char. And then I'm gonna just put it. And if it's not a space, I'm gonna take it from the stream. Taken char. Even when there is not a pending chars, we want to take it from the stream. Sorry. And taken char, the same. So that's it. Now let's start with the states. And the state 1, we're going to catch the character of the tokens, the letters, and determine it's a let bracket, as we did here. And if so, let's return a period type and set the position. Otherwise, return all as an error. So let me do it quite fast. Take the attach, append the taken char. If it's a left bracket, taken char. Taken char is a bracket. Let's just build the lexem to return it. It's equal to lexem. We have a type operator. Great. And in the last position, it's going to be stream, and it's pass. Let me just be sure of this. Okay, that's great. And return. Oh, If it's error, we need to put it as a lexem error, and the last position the same that above, and return off. I think I can do it better. Just I see. The only difference between this branch is the assignation of the type. So lexem operator else dot type lexem error, and either way we're gonna to get the last position from the string dot pass and return yeah, that's easy. With the case 2 we are going to take the letter also, but pass to the last bracket instead if it's a hyphen. Otherwise pass a row as a letsem as we did here, while holding the last position. So let's do it. Okay, it's all let me think a little bit. Okay, the same is equal taken char if it's a hyphen, we're going to change the state to 1. There is this one, it's a sequential case, and if not, I want to return an error. It's equal lexem error, and last position is equal to stream pass and return Okay, and the break. Don't forget the break. Now case 3 is for the IDs, the lexem IDs, where we determine whether the character is a letter, number, or an underscore. Otherwise, we determine the ID and put the char to the depending chars container, holding the position also, as the same of the cases. So this is for IDs, and if taken char it's letter or number, or if underscore taken char is equal to underscore sorry, we're gonna to append the letter to the token of the lesson that we are building, and change the state to 3, holding the state to 3 that we are currently having the same ID until it reaches a letter, until it reaches a space. So if it's a space something else, you can say that we finish building our ID. Simple. Equal lexem ID pending chars. I wanted to put taken, as we were talking about, it might be a white space, a blank character, and last position equal string dot pass return. Don't forget the break. So lastly, the case 4 is for comments, so we just need to determine whether it reaches the end of the line. It's quite simple. So it's another if taken is different to end of line. As token is equal to taken. Just keeping taking characters. Calling the state equal 4. Okay. If not, it reaches the end of the line. Want to finish building the lexem. So the type is equal to lexem. Oh, sorry. Comment. Yep. Last position equal to the same as we're doing in the previous cases. Return return and don't forget the break. So it may be a lot of information to this. Let me just build it. It may be a lot of information to this. Oh, what the fuck? Oh. Yes, it compiles, and maybe we're going to run it in next video. So it may be a lot of information. Hold on. It may be a lot of information. So I'm going to finish with this and letting the case 0. We didn't implement the case 0 to the first letter found, and then the file of the file reach at the end of the file handling. So I hope you enjoy it. Share with your friends and let a comment if you think it's correct or you have any doubt. Thank you. This was Carlos.